Homework 27, question 6. In this question we're given an expression for v which has three unknown constants. V equals pt squared plus qt plus r. We are given two conditions, which is not normally enough to be able to find three unknowns. We are told when t is equal to 0, v is equal to 11, and we're told when t is equal to 2, v is equal to 3. However, the third condition is that we're told that when t is equal to 2, the speed of p has its minimum value. This third bit of information allows us to solve the problem. The question actually asks us to find the acceleration of p when t equals 3, but we're not going to be able to do that until we figure out what our constants p, q and r are. The first one I'm going to substitute in is that initial condition, t equals 0, v equals 11. So at t equals 0, 11 is equal to p times 0 squared plus q times 0 plus r. Straight away that gives me the constant r equals 11. Now if I use that information as well as plugging in at t equals 2, v equals 3, I get 3 is equal to p lots of 2 squared plus q lots of 2 plus the 11 that I found earlier. And if I simplify this, I get 0 equals 4p plus 2q plus 8. This is one equation with two unknowns. Not much I can do with that for the moment. However, I can use the fact that I know that t equals 2 is a minimum. To find a minimum point, we can either complete the square in our expression or we can use differentiation, and I personally would favour differentiation. So dv dt is equal to 2pt plus q. And when t is equal to 2, dv dt is going to have to be equal to 0, because all minimum points have a gradient of 0. And this gives me 0 equals 4p plus q. And that is my second simultaneous equation. Now whether I use elimination or whether I use substitution, I can now solve these simultaneous equations. And I'm going to use elimination, and that leaves me with 0 equals q plus 8. Therefore q is equal to minus 8. And if I substitute that into either of my equations, I can then find p equals 2. And as always with simultaneous equations, I should check by putting it back into the other one, does it work? So I can at this point conclude that v is equal to 2t squared minus 8t plus 11. And now I can actually answer the question I've been asked to find the acceleration of p when t is equal to 3. Acceleration is dv dt. And that is 4t minus 8, and at t equals 3, a is equal to 12 take away 8, which is 4 meters per second squared. In part B, I'm asked to find the distance travelled by p in the third second of motion. So that is x equals the integral between 3 and 2 of my expression for v, 2t squared minus 8t plus 11. Now as I was told that v equals 3 was my minimum speed, I don't have to worry about any time when the velocity was dropping below the axis and partly above the axis to have to worry about negatives and positives cancelling each other out. I can just integrate between 2 and 3 without concern. So when I do my integration, I get 2/3 t cubed minus 4t squared plus 11t between 3 and 2. And if I do my substitution, that gives me 18 take away 36 plus 33, take away 16/3 minus 16 plus 22, and finally I get an answer of 11/3 meters.